This is Stacy Holder with a quick lesson on how foam block models can be used to take a look at faults and landforms. The first thing that you'll need to do is to gather your materials. You'll need a ruler, a piece of paper, something to write with, and one of these foam block models. You want to be sure that you have 3 sections that are all the same letter. Doesn't matter if it's a letter or a number, just make sure it's all the same. Then, when you orient it, you want to make it so that the line goes across the top of all the models. What this line is representing is actually the surface of the earth, as if that's us standing there. Let's say we wanted to dig a hole. There's my little shovel, and okay, that looks like an arrow, but it's a shovel. And if I'm digging a hole, there's my dirt being thrown out of the hole. I might end up with a hole that maybe I could see now if I look at it from the side view, like where these letters are. In other words, the letters here along the side of these blocks is representing inside the earth. If I were to cut away the surface along this point and look inside, that's where I might be able to see where these letters represent. Are there really letters inside the earth? No, of course not. Main thing to remember is that the surface of the earth is up here, and where these letters are along the side, this is representing inside the earth. To get your paper set up, all you need to do is to have a nice line drawn along the left side of your page. An easy way to do that is to simply line the ruler up with the edge of the paper and then just trace a line wherever the ruler falls. That makes it real easy, and you don't even have to worry about measuring. Then, when you set up your first block model, what you want to do is to make sure that the models themselves are lined up perfectly with that line that you drew on the paper. This allows you a really easy way to draw. You're actually going to be tracing the shape of the 3 different sections of the model, as well as measuring across the distance of the model. That way, if you have it lined up to this line on the left side, it's really easy to get some nice, good measurements. Once you have it set up properly, lined up properly, the next thing you want to do is to go ahead and get the things marked off. You want to mark off the places where the end of the blocks are over here. You want to mark off the places where the blocks meet together. That way, once the blocks are removed, it's really easy to just connect the dots and get everything traced. Don't forget to mark on the top edge as well. Then, before you move that out of the way, you might want to look real close at what measurement you're looking at. In this case, I'm at a number right here in between the 13 and the 14 centimeter mark. Each one of these tiny little lines is representing a millimeter. As it turns out, this particular measurement is going to be 13.5 because there's 5 of these little lines, 13.5 centimeters across. Once I removed the blocks, you can see that I have these dots here. And again, that just allows me to very easily do a quick little connect the dots to show where my 3 block sections are. The other thing that's good to do is to check to see what your distance came out as. If you did it carefully, you should be able to see that your drawing matches to the distance measurement. Remember, this was supposed to be 13.5 centimeters. And oops, I didn't really draw mine very well, but hopefully you'll have better luck. When you trace your lines, you could use a ruler or you can just freehand it as I did. Either way, it doesn't matter. By the time you're all done with your drawing out the shapes of the blocks, you definitely want to get some labels on here. I'm calling this first one the original landform without any movement, without any change, and I'm marking this as having no fault. No fault means that there's actually no movement here along these spaces in between the blocks. So with no fault, it was again that 13.5 centimeter measurement. My middle model that I set up is going to be called the normal fault. The normal fault is going to have some movement. The movement in this case is that what happens is that both of these blocks on the outside end up moving outward. As these blocks pull away from each other, this big middle section, this big chunk in the middle, drops down. When you go to line it up, though, you do want to be sure that you've lined up that edge, the very left side of the model, you want to line that up to the line that you drew earlier. That way, you can go ahead and trace this out and measure it, and it'll be able to be compared to the one above it. Again, you should have that line across the top of the models should be right here, all along the top of your sections as you have them laid out. Keep in mind that what that represents is that somebody's standing up here on that surface. This is the surface of the earth. In other words, this place right here, where there's this big jump, this must be a place kind of like a mountain or a hill. In other words, this is actually one of the ways in which mountains are formed. So taking a look at what we've done here, I should be able to measure it and have a nice measurement, nice accurate measurement done. I want to do the thing where I mark off all the little edges. Oops, that didn't come out as a circle there. All the edges, I want to do that along the top as well. That way, once the blocks are removed, again, you can do the thing where you're tracing it out and you have all the different shapes. You should also check that measurement right here. This one comes out to be about 15.2 centimeters across. Wait a minute, the one up above was only 13.5 centimeters. By having these blocks move the way they did, that one moved outwards, that one moved down. Something very interesting happened here with the measurement across this landform. And we'll keep that in mind. Go ahead and get your labels done, calling this the normal fault, showing the direction of movement, and getting the label of your measurement. Last one that we do is going to be called the reverse fault. If the normal fault had the outside blocks moving away from each other, the reverse fault is going to have these outside blocks moving towards each other. Well, then that means this big chunk in the middle has no choice except to pop upwards. It's kind of like it's being squeezed out of there. Once you have that into place, make sure that you've lined up along the left side. Go ahead and mark everything off. You've got your nice little marks here. You might even find that you need to kind of trace this weird triangle here in the middle. That way, once everything's moved, see, here's that weird triangle right there. That way you can get everything lined up properly. Once you have that part done, go ahead and get your measurements done. This time I come out to about 12.0 centimeters. And again, I've got all my arrows drawn to show the direction of movement. Once I have that part done, the last thing to do is to go ahead and take a look and make a statement here about how the normal fault and the reverse fault are different. I've sort of alluded to that about what those differences are, but now you can put it in your own words. Comparing the measurement across the normal fault and the measurement across the reverse fault, what can you say? What would be a good thing to add in there to finish up those two sentences? This has been a 96-second science production because there's always time for a little science.